Raz, dwa. Działa? It's Monday. You're sipping your coffee and you just opened Trello. There's one ticket to do, and it says perform a slam dunk. Now, as any other developer, the first thing you do, you move the ticket to doing. The second thing you do is check what you have to do. And the third thing you do is opening your code editor and start editing and praying. Yes, that's an ambitious ticket, so you will need some praise there. Though, if you think about it, you're actually working with software, right? So you make the rules. So why don't you just buy a trampoline and boom, done. Or you could just go to the moon where you weigh 6 times less and performing a slam dunk is just like a walk in the park. Now, the thing is, if we manage to focus on the goal we have and actually unbias ourselves from the tools we normally use, frameworks, languages, technologies, we can actually achieve seemingly impossible tasks. And in fact, it's still Monday, you performed a slam dunk. Not a bad week already. Now, Tuesday, you're again sipping your coffee, and you open Trello. Again, another ticket to do. It says write bug-free software. Now, this time you're smarter, though, because you will not move this ticket to doing until you're sure you're able to do it. Because you don't want to assign the ticket to yourself. If it turns out you cannot do it, you will leave it there. Somebody else will take the blame, right? So let's step back for a second and think about this ticket. So JavaScript was developed in the 90s by copying Java. TypeScript is a superset of JavaScript and is unsound as a type system by design. Because you cannot really add types, turns out, to a language that was not designed to have types. It's so dynamic in a silly way that you cannot really do this work so organically. You're going to find some corners that types don't really cover so well. On top of it, TypeScript is a bit of a leaky abstraction, right? Because if you're a TypeScript developer, you still need to kind of juggle two things, TypeScript and JavaScript. And then, of course, you npm install, and you bring in whatever the community is doing on top of those foundations. Now, there's a fantastic paper I totally recommend you read. It's called Out of the Tar Pit, and they say, this was, by the way, 2006, so it's worse now. The biggest problem with nowadays software is complexity. And it's exactly complexity where bugs thrive. Not only that, we actually believe that bugs are in the nature of software. And in fact, we don't even try to avoid them in the first place. We cope as an afterthought. We do a lot of things after the fact, after we put bugs into our software, to cope with the problem. And I guess the most meaningful part of this is in the word, bug. We should probably call them mistakes, right? Because if we take the blame a bit, if we feel a bit ashamed, maybe we have a bit of an encouragement to fix the problem, not try to think of it as just as an afterthought. And I'm pretty sure some people here are thinking, yeah, but I know that TypeScript has some kind of silly corners, but I'm just using the good parts. And the question here is it okay to use a bad tool well? Even then, are we sure your entire team is aligned on what are the good parts? And even then, is the community aligned? Because last time I checked, already in React, you can find almost 100 ANYs in the typings. And again, it's not surprising, because React is not written in TypeScript. They add the types as an afterthought. And of course, those types cannot be so well implemented because they are added later on. All of these things, in my opinion, stem from one particular reason. We are sacrificing everything because we want compatibility. We want familiarity. I mean, if you think about it, even in React, we couldn't stand not having HTML in the components, right? So we keep trying to have this familiarity all over the place. And we should probably step back for a second again and think about what's the goal. Because if the goal is to reduce complexity, thus reducing bugs, then maybe we're not doing the right thing. Maybe it would be way better to design our tools, our languages, our technologies, with the idea of pits of success, where something is easy to do because it's the right thing to do, and something is hard to do because it's the wrong thing to do. Now, before we get into it, a couple of words about me. As Pavel said, I was lucky enough to be in many places, so I guess I collected many nicknames over time. I'm super curious to hear what's your your favorite Italian word, so come to me afterwards and let me know. And I'm working as a full-stack product engineer, currently on improving the developer experience at knapsackpro.com. If you have a test suite that takes a long time, and long means that you have to open Twitter because you cannot stand waiting for the build to finish, we will be happy to help. We have several clients with hour-long test suites, and we managed to bring them down to a couple of minutes with optimal parallelization. Okay, so I will be using Elm as a language for the rest of the talk. But I will not show you any Elm, because Elm decided that compatibility and familiarity are things that can be sacrificed. So I don't want to get us bogged down into details, because the syntax is strange and all of that stuff. But I have two goals for this talk. One is to make you interested about Elm, to actually convince you to give it a try, because I'm convinced that it's going to change your life if you learn it a bit. The second point and the second goal for this talk is that I want to share with you the wisdom that we can find in Elm, because there are many things that I'm sure we can apply to our everyday job, even if we're not using Elm. Now, why Elm? Because Elm guarantees practically zero runtime errors. There are people with hundreds of thousands of lines of code in production. They've never seen a runtime error there. And I have the same experience with tens of thousands of lines of code. The only exceptions I've seen in Honeybadger were coming from JavaScript that I was running side by side with Elm. And you probably are asking yourself, how the hell did they manage to do that, right? So Elm recognized that there is good stuff in software, but it's way diluted into a lot of silly ideas that we need to be compatible with, so we keep accumulating them over time. Now, let me show you how Elm approached bugs by reducing complexity. So I took the cheat sheets from the TypeScript website. You don't really have to read the details here. But the point here is that Elm took a look at classes and said, you know what, that's just complexity. Let's just remove it. Then Elm took a look at interfaces and said, you know what, yeah, we don't really need that. Then Elm took a look at type narrowing in TypeScript. Not needed. And then Elm saw static types. And it said, you know what, static types are super cool. But we can just make it simpler. And we can also remove this, any, undefined, not a number, triple equal, and all of that stuff. Not only that, in the Elm community, they realized over time that people were using the language in a way that always converged into the same sort of patterns. And they also realized that if you manage to design some tools to work well, one with the other from the ground up, those things, strangely enough, work better together. So Elm is not only a language, Elm is a package manager, Elm is a framework, Elm is state management, immutability, types, functional programming, and schemas. You don't have to install anything else. Whenever you're using Elm, you're using all of those things at the same time. And the surprising thing is that I showed you 4 cheat sheets for TypeScript, and they are not the entire language. But this cheat sheet is pretty much the entirety of Elm. And this cheat sheet also includes 2 applications, terminal commands, additional tools you could use, routing for single-page applications, and many more patterns people use in Elm, just in one cheat sheet. And to drive it home, these are the lines of the compilers. Elm is 50,000 lines of code. Elm is 1,400,000. And again, Elm is not just types for JavaScript. It's much more than that. Legend has it that when Marie Kondo saw the previous slide, she started crying. True story. Now, the first piece of wisdom here is whenever you have an accidental complexity, remove that complexity first. As Ken Beck said, make the change easy, then make the easy change. Let's go on. There are two functions here. I guess we all recognize the left one is the simplest one because it's pure. It takes input, returns output, done. The one on the right, you need to remember to catch whenever you call it, so you need to wrap the code because sometimes it throws an error. You cannot compose it because it's logging the result to screen, so you cannot do anything with the result after it's logged. And to test this is a hell because it's dealing with global variables and mutation. And this is just 7 lines of code. And in your program, you don't have this function for sure. You have more complex stuff, and it accumulates complexity way faster than these silly examples I have on my slides. The other thing is, another 2 pieces of code doing the same thing. The left one is way easier to reason about and work with because it's immutable. Now, this is not news to anybody, but it's news because when Elm saw that, Elm realized that many people say, you know, you should write most of your systems in pure functions and immutable functions because that's just way easier to handle and to deal with. But what Elm decided to do is, you know what? I will not even allow you to do anything that is mutable or anything that performs a side effect. You cannot do it at all. And now you may be asking yourself, okay, well, I cannot write for loops, I cannot do a fetch. What the hell can I do with Elm? Now, let's take a look at how fetch works in TypeScript and in JavaScript. So whenever the runtime sees fetch, it starts already the promise. It's already running. Now, this is a bit of a problem already because you already lost a bit of composability right there because you cannot do anything before that promise is started unless you do some magic trickery there. And 2 big problems additional to this is that I see a lot of people writing that type there, and this is effectively a cast. This is saying, you know what, compiler, I totally guarantee you, this is going to be a user. Don't worry, 100%. And then you push it to production, it wasn't really a user. You know, sometimes you get from the API something that is a user without one property, or that property was supposed to be a string, it's an integer, too late. And the other one is, it's way too easy to forget a catch. And again, if you forget a catch, the catch will remember about you, and it will explode on production again. Now, in Elm, you never really perform a fetch. You declare you want to do a fetch. This is way better. First of all, because this is just an object. It's easy to deal with, it's easy to test, it's easy to do whatever you want with it. It's also immutable because in Elm you don't have any mutability. Also, whenever you declare a fetch, you need to give it a decoder first, and the decoder is saying what you're expecting from the API and how you will parse the value the API gave you into the type you are expecting, in this case a user. The second thing you do is you say what function you want to be called after this fetch is performed. Now, the beauty of this is that Elm takes into account all of the possible things that could go wrong. And it gives you back, after performing the side effect, a result that you have to destructure. You cannot use any of these values without destructuring. So it's impossible to get a runtime error out of this, because anything that could go wrong, you have to handle while you're doing the pattern matching, including the last bullet, which is bad body. So if the API gives you something that, according to your decoder, is not a valid user, Elm will realize it, and then you have to handle it. So this is a way to completely remove runtime errors. And the thing is, it's incredibly difficult. It's almost impossible. I guess it's impossible to lie to the Elm compiler practically. This is the difference between being confident and working with guarantees. So in the community, they say, in the Elm community, they say, make impossible states impossible. So allow your program to construct and to behave as your domain, sort of like, as your domain is supposed to be behaving, but disallow completely invalid states. And to go deeper into it, I see a lot of TypeScript developers coming up with types like this, which kind of makes sense at the beginning. So you have some data that you're going to be fetching, and you design it around this type where at the beginning you have a null because you still haven't performed the request. Then it's loading. Then maybe there's an error, so this error goes to true. Or you get the data, and then you have your value of type T. Now, if you have the type, you can actually construct this value, which means you have a user, it's still loading, and it's errored. What the hell does this mean? Nothing. And this is a bug waiting to happen, because that type allows that value to exist. Instead, this would be probably a way better type, because we are making impossible states impossible here. And the fact is that you can do this in TypeScript, but Elm teaches you all the way, all the time, to think with types at the beginning, not at the end. Many TypeScript developers write JavaScript, then realize the file ends with TS, and then they start adding types. And then you have the same problem with the React typings, because types added at the end are not going to be organically working well with your logic. So this is something that Helm teaches you a ton. It gives you also a really great syntax to work with. By the way, if you want to explore this topic a bit better, I have a YouTube video on my channel where I go through this from the perspective of TypeScript and not Elm. Now, I also told you that Elm is a framework. So framework comes with this idea of you are supposed to put some specific code in some specific places. But the problem is you can pretty much do whatever you want in those frameworks. In Elm, there's only 3 places where you can put code. The model, which is the only global state of your application. The update function, which is the only way to update the model. And the view function, which is the only way to turn the model into HTML. And it's not like, for example, in Rails, where there's an anti-pattern that is called fat controllers, because people tend to put a lot of code in the controllers. Or in React and Redux applications, you always have to think, okay, is the state in the store or in the component? Or at what level of the hierarchy of the components? In Elm, you cannot do it. In Elm, you're obliged to put some stuff in some specific places. There is absolutely no choice. So those mental cycles are they don't even exist in Elm. Now, if we take a look at the diagram for Elm applications, and maybe you can mentally substitute Elm with React, this would be a Redux React application. So you have the update and the actions, whatever the names are in Redux. You have the store, and then the view talks with the runtime to perform the diffing and render the DOM. Now, in Elm, you also have those 2 arrows here, which is exactly how you can perform side effects, exactly as the fetch they showed you before. You tell the runtime, okay, I want this stuff to happen, do it for me. All of the nasty side effects, mutability, stuff you don't really want to deal with because you don't sleep at night otherwise, happens in the runtime, which you don't manage, somebody else is testing it, and the part of the application where you work is all pure and simple. And again, it comes with this idea of you have a framework, but this time there's only one place, and that's always the right place. Now, a few years back, I was working on this app, and it was written in React and Redux. And I guess I was thinking in React a lot, so I saw a lot of components. There's a filter, there's a tag, there's a card, so on and so forth. And then I started digging deeper in the mockups, and I noticed that that filter contains some checkboxes, and each checkbox has associated results. Now, I asked the client, and they told me, you know what? That's the amount of results you would see if you selected the checkbox. Okay, cool. So I selected the checkbox in the mockup just to see what I had to do with that. By selecting it, one tag appeared at the top of the search that I could unselect. A badge with the amount of filters appeared at the top of the filters with a clear all button. The amount of results was shown at the top of the search. all of the other filters associated results had to be updated because now we're looking at the subset of the data. And there's also a download and a save search button. And there was a ton more stuff. I was sweating like hell when I realized I took this ticket and I assigned it to myself. It was too late though, so I had to actually make it work. And I started with these single components independent from each other. And then I started realizing that all of this data is the same data shown in different components differently. And the behavior also is shared by all of the components. So by working in a way where I thought the components were independent, I put myself in a state where I couldn't actually make it happen. I had to bubble up the state, I had to bubble up the behavior to make all of this work. Luckily, there was Redux already, so I could make it happen. But I kind of was angry at React because it gave me a super strong idea on how to structure apps, and it broke down. In Elm, I like it much better because the idea is you don't have any components. You have a view function to which you give your state of the entire application, and that state percolates through all of the view function and then all of the other view functions you call from your main view function. So the idea in Elm is apps are a projection of your data. Data is the center of your app, not components. So I find myself that this abstraction is way, I guess it's simpler, but also doesn't really break down. I find that most apps, the non-trivial ones, always revolve around data, not really components. Components work well in the view layer, but when it comes to behavior and data, then I don't think it holds so well. Now, a couple of words about performance. On the left, you see Elm compared with React. Elm is greener on every possible metric here. And it can do that because being completely mutable, being completely pure, it can apply some performance optimizations then that, for example, in React, you would have to really think well about. Pure component, use memo, or wrapping your components in a memo with a specialized differ, should component update, so on and so forth. In Elm, you just don't really have to do that because you have all of those guarantees of immutability. So all of those things kind of work by default. And another thing is that Elm is also super small because Elm apps get bundled into JavaScript, and that JavaScript being small is actually probably a good idea. And the fact is that Elm, with all of these its guarantees, it's not dynamic as JavaScript, so it can perform tree shaking at the function level. So if you install an Elm package that contains 1,000 functions, and you use only one, in the bundle, you will only find that one function, and 999 functions are removed, which is something that in JavaScript, it's not really practical to do so consistently with guarantees, because JavaScript is really dynamic, so you never know if a module you are importing, what functions from the module you're actually using or not. Now, I really hope that I showed you how Elm is safer, purer, faster, and simpler, at least in the things it does. And I want to also share that there's a couple more cool things that I will not cover so well in this presentation that I think would be interesting if you want to try Elm. So one is that the package manager enforces semantic versioning. You cannot publish a version of your package that bumps the patch version and you change the type of a public function. You cannot do that. The compiler stops you. There's also this idea of a debugger, which we have probably seen in Redux, but in Redux you see a lot of warnings about, you shouldn't mutate stuff, you shouldn't perform side effects because otherwise stuff breaks down and things don't really work so well. So since in Elm you cannot mutate things or perform side effects, all of this stuff really works well, so you can actually navigate through the history of your application, through all of the events that the user triggered. And also you can actually do some other cool things, like you can export the session, re-import it in another browser, and see that session again later on. This is useful if you have a tester, for example. The tester can tell you, I found a bug. You can just reproduce it yourself. The compiler in Elm is awesome. The best error messages I've ever seen, probably even better than Rust to some extent. It actually tells you all of the things that are not working, why, what you should do, and most of the times you just do what a compiler tells you and stuff works. Or at least these compiler errors you can understand, which in TypeScript sometimes is not the case. And also, last thing I wanted to share is that you can still use JavaScript side by side with Elm, but with all of the guarantees that Elm gives you, there's this sort of idea of a port where you can communicate between Elm and TypeScript, and whatever is happening on the JavaScript side, it stays there, but you can still use it. So the mess stays on the other side. You can keep drinking your mojito. Now, I really hope that I made you curious about Elm. So if you are, maybe check these links here. Those are great places to go and check out Elm. And I really hope this gave us the courage and the tools to look at this ticket and bravely assign it to ourselves and move it to doing. And finally, hopefully, better sooner than later, we will get rid of all of that complexity and all of the bugs. Thank you very much.
Do we have any questions to Ricardo? Okay, there is two. I will lazily choose the guy closer to me, sorry.
Thanks. Thanks, Ricardo. You got my attention, definitely. So Elm looks interesting. Could you tell me, because Elm is new to me, if I am to choose it and to use it, to learn to use it, we have React, for example, which has a multitude of libraries, of plugins, additions that we can use. Of course, they might be buggy, but we have a multitude. So the learning curve is quite easy. It's quite good because we have a multitude of tools we can use. How is it with Elm? Everything is built in, but well, how many tools we have that can help us start with, so that we don't have to build from the ground up everything by ourselves.
So I want to preface this answer, thanks for the question, by the way, because it gives me the opportunity to say something. So I don't really want to convince anybody here that Helm is something you should be using on production. That's a choice you're making, especially because if you're coming from JavaScript, the Elm community is incredibly slow. So you are not going to see a lot of those things that are happening in Next, Vercel, all of that, because it's way less community, it's more of a niche. So like my point here was to show you why I think Elm is cool, and maybe we can use that as an inspiration for our work. I can tell you that Elm, with the idea of ports, allows you to kind of, we did it at work a few times, where we had the Elm application inside of an Angular application, and then we started developing new features inside of Elm, and Elm grew up, and then we built another Elm application inside of Angular. So we had two Elm applications inside of Angular, and they started growing like the strangler pattern. And then at some point, it got to a point where we had more Elm than Angular, and we moved everything into Elm with an Angular app on top, and then we finally migrated out. When it comes to tools, you can pretty much use any JavaScript library you want, because there's this idea of communicating back and forth, like the actor model a bit. So for sure, there are ways to incrementally adopt it. Then again, warning for you, I'm not pushing you to do it on production. It was more like, let's learn from a niche language that maybe not many people know.
Okay, but if I import or join a tool from a library designed for React or JavaScript, then I invite bugs into Elm, right? Because I don't know what import, as you said, I can import many functions that can be.
So the way it works is like there's a wall in between Elm and JavaScript. You cannot bring bugs into Elm because Elm guarantees that whatever comes into Elm is the correct thing. I know it's strange to think about, but the way it works is that it's completely isolated. You can still talk from one to the other, but there's this isolation that guarantees you that in Elm, you're not bringing any more bugs because there's some JavaScript on the other side.
Let's have one more question, and then the rest will come to the networking part. Thank you.
Great talk. I have a question similar to the first one, actually. There was like this, the view is the function of your state, right? Something like that. So in Elm, you've shown us that you have those controllers and views and models. So how that differs from, for example, React or with proper architecture when you abstract stuff and you have just like components that are mostly dumb as could they be, right? And you abstract all the stuff outside. So is Elm just taking care of that out of the box as a language, or?
So in Elm, for example, you cannot have state outside of the model. So in React and Redux, for example, you can choose the state is in this component, is in this component above this other component, it's in the store, in the Redux store. In Elm, you're obliged to put some things in specific places. I guess you can still write a Redux React application following the same principles, and in fact, Redux was inspired by Elm. But the point is that Elm kind of obliges you to do some things in some specific places, while Redux, being inspired by it, kind of allows you to do things, but then you still have to think, should I put it here, there? And then also you're left to, like, again, to all of the sort of silly things that come with JavaScript and TypeScript, because you're not constrained in that design thought upfront, like in Elm. So yeah, I guess the answer is you can still do all of the things you would do. You can reproduce Elm in React and Redux, but I guess what really helps me when I'm using Elm is that it gives you this sort of like super sophisticated but also super simple architecture to work with. And it removes a ton of decisions you have to make from the table. So you're left there thinking about your domain rather than thinking, okay, I will put this state here. And then you realize later, no, it should be here. No, it should be here. Instead, it's everything up there. So you cannot even move that state. It's always in the store. So it simplifies your life in that way, I guess.
So you could say that the language kind of enforces you to use some sort of a Flux architecture pattern or something like that.
Yes.
Okay. And the second question about the adoption, like, for example, like, great, Elm seems awesome, but when you need a new member in your team, you need to hire people that know Elm actually. So do you have like any knowledge about that, like experience?
In terms of hiring Elm developers?
Well, you know, like, how is the Elm popular and stuff?
So it's not as popular as React, that's for sure. The fact is that it's a bit like Python at the beginning. It seemed like strange that you could find so many Python developers, but it was the case because Python was so cool, nobody was using it at work. So the few Python developers were super easy to find and were super happy to use the language. A bit like Haskell in some circles, maybe a few years back. So I guess you will always find developers in a way because it's a niche thing that people who are in the niche are super into. But for sure, it's way smaller than JavaScript, React, and all of that.
Thanks a lot.